Next, I will show you the answer of practice 1. This practice is for the correlation. Facer and Gisser, all of your assignments are very good. It means, yes, you grasp the knowledge of correlation and regression. That's great. Still, there are something you need to add in your practice, and here I will show you. First, practice. Use the data. Analyze whether the relationship between bust and hip is significant. Okay, for this question, besides the correlations, Facer showed the graph. The plot of the scatter of bust and hip. That's good. Okay. So for Gisser, also here you need to add a plot like Facer. Okay, because it's very important. Firstly, you need to draw the scatter. So from the scatter, you can see that the hip and the bust, it shows they have the linear relationship. Then, next, you will use the correlation. This process, Gisser is correct. And Facer, you lose this output. Okay, so for Facer, besides the graph, because graph is the first step. Through the graph, directly you can see these two variables has the linear relationship. Then next, you will use the correlation analysis, the Pearson coefficient, and also if the correlation, the coefficient is significant or not, to confirm that the relationship, the linear relationship between bust and hip is significant. Okay, so if your answers combined, then it's totally correct. Okay, yes. So Gisser add a scatter, and Facer add the coefficient. Okay. And from your results and conclusion, it means yes, you are okay. From the scatter, graph shows linear relationship between bust and hip is no significant. You can't say it's significant or not. You just can say from the scatter dot, graph shows linear relationship between bust and hip. Okay. And also, the homoscedasticity hasn't been violated. And then next, I copy Gisser's. Yes, the Pearson correlation of bust and hip is 0.486. The p-value is less than 0.001. So the correlation of bust and hip is very significant. Then it's okay. Now, it's the answer of the first question. Got it? Okay. Second, whether the relationship between waist and hip is significant when bust is controlled in the analysis. Okay, all of you is correct. Okay, the control is bust. And after the bust is controlled, the partial coefficient is 0.459 with the significance is less than 0.001. So it indicates that when bust is controlled, the linear relationship between waist and hip is significant. Okay, so yes, all of you, both of you are correct. Great. Next is the practice 2. Do both bending rigidity and shearing rigidity impact on drape coefficient? Which is the best predictor of drape coefficient? Here, for this question, if you use the linear regression analysis, firstly, you need to draw a scatter, okay, to analyze if the variables have linear relationship. So it's very important. Firstly, you need to judge. Okay, so the scatter here or both of you don't have, so you need to add them. Okay. Because the practice is if the bend rigidity and shearing rigidity impact on drape coefficient. Not this one. Okay. Here's the draping coefficient, and firstly, you need to use the matrix scatter. Yeah, the Y is draping coefficient, x1 bend rigidity, x2 shearing rigidity. Okay. So here, you better to okay, let me see. 1, 2, 3. Yeah, if I want to use a copy this. Yeah, that's the first step. Okay, and from here you can see that the draping coefficient and the bend rigidity I would like to use the Lewis here. Okay, and from here it seems like the bend rigidity and the draping coefficient And also here is the shearing rigidity and draping coefficient. In fact, look here, their relationship is not the linear relationship. Also the shearing rigidity too. Okay, it's not the, it's close to linear rigidity, but it seems like a curve. And also here it seems like a curve here. Okay, so yeah, now let's skip this step. Okay, we think if we think they are linear rigidity, they are linear relationship. It's just an example. So we think, we regard the draping coefficient and the band rigidity, they have the linear relationship. Also the shearing rigidity and the draping coefficient, they're close to linear relationship. Okay, so I do it, firstly I do it like this. But in fact, they are not the linear relationship. Okay, so here it seems like they tend to have linear relationship. Okay, so we just say they tend to. And then next, let's check there if they do have the linear relationship, the coefficient is significant or not. Then we could use the analyze, the correlate, and there's a y, x. Okay, here is the correlation. And from the coefficient of correlation, the draping coefficient, here's the draping coefficient, right? The draping coefficient and the bending rigidity, the Pearson correlation is 0.553, with the significance is 0.026, which is less than 0.05. So it's significant at 0.05 level. For the shearing rigidity and the draping coefficient, the Pearson correlation is 0.771, with the significance less than 0.001. So this Pearson correlation is significant at the 0.01 level. It means the shearing rigidity and draping coefficient, their Pearson correlation is very significant, right? Okay, so here means band rigidity and draping coefficient is significant. Shearing rigidity and draping coefficient is significant. After these two judgments, then next it means band rigidity, shear rigidity, x1, x2 can input into the model, the regression model, to predict draping coefficient. Okay, so GSR and phaser, you lose these two, the graph and the coefficient, the correlation. Okay, after this, then next you can use the linear regression. Okay, so firstly, draping coefficient, then banding, shearing. Okay. Firstly, you use the enter, the method enter, the default method enter, right? Okay, here the R and here GSR and phaser, you are right. From here, the coefficient, yes, here the t-value of band rigidity is 1.792 and the signature, the significance is more than 0.05. From this, we can say that the band rigidity has no significant impact on draping coefficient, right? On the contrary, shear rigidity, the t-value is 3.838 and the significance is less than 0.01. It means shear rigidity has very significant impact on draping coefficient. Yeah, that's great. But besides this, you also need to paste this. It's also important. The ANOVA. Okay. The ANOVA is also important. So also here, you need to paste. Because it's ANOVA is basic. It means the regression model established is significant. F value is 13.47 with the significance is less than 0.01. Okay, so that means the regression model is significant, and then look at the coefficient. Okay, so here you need to add 1, and then here is 2 and 3. Okay, which is the best predictor of drape coefficient? For a reliable regression model, it's important that all the variables in the model, their coefficient should be significant. That the model should have this under this condition. Okay, but this time in this model, when we input band rigidity, shear rigidity in the model, the band rigidity, the coefficient is not significant. It's more than 0.05. So that means this model, this equation is not reliable. Okay, the GSR is very good. Yeah, through here, GSR write down the regression model. Draping coefficient equal to 7.350 at 0.355. Multiply band rigidity at 10.832. Multiply shear rigidity. Yeah, it's correct. Yeah, the band rigidity has no significance. So this calculation may not accurate. Yes, right. Or you can say this regression model is not reliable. Okay. Yeah. In this case, it will be changed the method to stepwise. Great. Great. Okay. Also here, I explain this one. Here we have a standardized coefficient. Standardized coefficient means all these y, x1, x2 will be transformed to a standardized value. Now, the band rigidity, the shear rigidity, look here. The band rigidity and also here is shear rigidity. Yes, they use their data. Here is 0.1, 0.12, and all of them, they don't have the same. They are not the standardized value. If all of them are standardized, then you can get the coefficient like this. Yes, I think I would better to show you. For example, the band rigidity. If we use the band rigidity standardized, G shear rigidity standardized, and the draping coefficient standardized, then look here, analyze, descriptive. Okay, all of these variables. I save standardized value as variables, right? Okay. So here is Z, standardized band rigidity, standardized shear rigidity, and standardized the draping coefficient. Okay, all of them, the mean value is 0, and the mean is 0, mean is 0, means 0, so they are standardized. And then if you use the regression, the linear regression here, for example, draping Z, F, ZB, ZG, yeah, look here. Now, unstandardized coefficient is 0.306. The standardized coefficient 0.306, 0.656. They are the same. Okay, and also the coefficient is same with this. Okay, so I just show you what's the standardized coefficient mean. It means if all these variables are standardized, then you will get the standardized coefficient. And since all these variables are standardized, so higher this coefficient, the important or the impact of this variable is higher. For example, now here the shear rigidity, the standardized coefficient is 0.656. The band rigidity, the standardized coefficient is 0.306. So that means for these two variables, shear rigidity has the higher impact on draping coefficient because the standardized coefficient is bigger than the band rigidity. But if you compare the unstandardized coefficient, then because their data is different, so also the understandardized coefficient, you can't compare them. There's no, it's not bigger, more important. But for the standardized coefficient, the data is, or the value is higher, the value is bigger, more important. It's a more important factor to effect on the y value. Understand? Okay, so I think I needed to explain the standardized coefficient for you here. Got it? Can you understand? Okay, it means the higher the standardized coefficient, more important factor. Okay. Also, I think okay. So here, it will be changed the method to stepwise. Okay. Then you need to use the stepwise, the method transfer from enter to stepwise. And then okay, and then please select the plot. The plot is y. Yeah, okay, yes. Save the predicted value unstandardized. Okay. Now you will copy this and over. And copy the coefficient. I told you because this is basic. Okay, it means the model you established is significant. Then look at the coefficient. When we use the stepwise, the band rigidity is excluded in the model. And in this model, just shear rigidity is included. And also the t-value is 4.527 with the significance is less than 0.001. Okay? Therefore, the coefficient of shear rigidity is very significant. The shear rigidity has significant positive impact on draping coefficient. Okay, and according to the new desired, the predictor can be written as draping coefficient equal to 11.646 add 12.737 multiply shear rigidity. Okay, and also this is the best predictor because the shear rigidity, the coefficient is significant. Okay, that's the assignment. Also here, I think I'd better to show you the R, what's the R means. No, not this one. This one. Yeah, here we have the model summary. We have the R. 0.771, R square 0.594, right? I show you where do these values from. Here, I save the predict, right? What's the predict mean? Predict means we use the equation. We use this equation. We use this equation to calculate the draping coefficient. Okay? I think I'd better to calculate it. Look here. Here is calculated automatically by the computer. Also, I can calculate it. I will calculate it. Copy this variable. And then transform. Paste. Okay, I will use the equation established by GSO. It's 11.646. Add 12.731. Multiply Shearing rigidity, right? Because in the best predictor, we just have the shearing rigidity in the model. And here is the regression model established by GSO. Okay. Okay, let's compare two of them. Look. Here, I use the equation to calculate. And here is automatically output and automatically calculated by the computer. Also, the computer uses the same equation. Okay, so you can see what's the predicted value mean. Okay, and in fact, it's calculated with the equation we established. Next, I show you what's the R mean. The R means the predicted value of the draping coefficient and the draping coefficient measured in experiment. If the prediction is 100% correct, then the R value should be 1. Now, look at the graph first. Here is the predicted value. Here is the measured value, the real value, the predicted value. Look. Here the draping coefficient and the predicted the draping coefficient. We can see that it's not a linear line. It looks like a curved line, right? But still, you can have a R predicted F and the F here. Look here. Can you see it here? the Pearson correlation of draping coefficient and the predicted draping coefficient is 0.771. 0.771. And also you can see the model summary R is 0.771. Okay, so R square means R multiply R. Then you can calculate 0.594. Okay, so that's the value. Where the value from? I show you where the value from. And also, also let's back here. In fact, from the graph, you can see that the draping coefficient and the bending rigidity, they are not the linear relationship. Also, the shear rigidity and the draping coefficient, they are not the linear relationship. Okay, so if we use the linear regression, in fact, it's unreliable. It's not reasonable. Okay, so I would like to show you their real relationship. They don't have the linear relationship. In fact, they have the curved relationship, nonlinear relationship. Okay. Also, from here, we can see that the predicted the draping coefficient and the real draping coefficient. Look here. They have the curved relationship, right? Okay, so here I would like you to firstly the shear rigidity and the bending rigidity. We will calculate their log. Yeah, but I think I'd better to stop here first and then restart.